Hi guys, I think we can start because it's time. So, my name is Jakub Knetl and I would like to introduce you one concept of messaging system which is based on Apache ActiveMQ. Because I work at Red Hat as a quality engineer and I'm testing mostly JBoss Fuse and JBoss AMQ products which are based on Apache ActiveMQ. And there is a replicated LevelDB protocol which ensures the high availability of the messaging system. There are lots of more scenarios, but the replicated LevelDB is the new and it has lots of advantages in order to be better than the previous one. But first, I would like to tell you some basic concepts of the messaging systems, and then after that I will move to high availability scenarios. So messaging systems are used for exchanging data, but if you want to exchange data between your distributed application or different applications, you need to ensure that both sides who wants to communicate have to be online at the same time. But with the messaging system, you get lots of disadvantages. First of all, the clients don't have to meet themselves online at all because all data goes through the broker, which is running on some server, and consumer of the data can connect and download the data, which are stored on the broker. So both sides doesn't have to be online at the same time. You also get a wide set of clients, so you can integrate multiple platforms and applications in multiple programming languages, which is also a great advantage. You get also scalability because you can deploy more brokers to do load balancing or something like that, so you can get better performance for your application. Some terminology. So message is amount of data you want to transfer. It consists of headers, which are some predefined headers, and also you can define your own headers. And then there is a body, which is the content of the message you want to send. On one broker, you can have multiple destinations because probably you want to have more application to communicate through the broker, or for maybe just one application but to exchange different data. Clients can produce data to send data to the broker. These clients I will call producers, and there are also consumers which are for downloading that data, but the client can be both producer and consumer, so something like that. There are multiple types of communications. First, the most simple is point-to-point communication. So in this case, destinations are called queues, and all messages from producers are enqueued to that queue, and they are stored here in that queue until some consumer came up online and downloads these messages. When you have multiple consumers, then only one of them will receive the message. If there is no consumer connected to the broker, then message is stored until some of them will came up online. So here you can see simple animation. You can see one producer, and when it sends message, it goes to one consumer. When it sends another message, it probably will go to another consumer because the broker tries to balance the load between the consumers. You can use it, for example, when you have some distributed application. For example, your producer can be some measuring system, and the consumers can be some workers which will process the data. So they will fetch data from queues, process it, and then publish it somewhere, probably to another queue or whatever. The second type of communication is publish-subscribe model, and in that model, every message which is sent to the destination, which in this case is called topic. So every message sent to the topic is delivered to all connected consumers. These consumers are in this case called subscribers. So everyone who wants to receive the data has to subscribe to the broker, and then it will ensure that data will be transferred. When there is no subscriber, then brokers suppose that no one wants to receive message, so the message is thrown away. There is also a special case, it's durable subscriber, and with durable subscriber you can subscribe and then go to the offline mode to disconnect, but the broker will store message for you, and when your durable subscriber came back online, then he can download the message which he would miss in other case. So when the message, some publisher sends message to the topic, broker will duplicate it and send it to all subscribers, so everyone gets the message. So now I would like to introduce you some basic concepts of the JBoss Fuse, because it's much more than messaging system. It's a whole enterprise service bus, and it has integration framework for web services, and it contains also messaging system which is based on Apache ActiveMQ. So here you can see the structure of JBoss Fuse. There is container which is based on Apache Carafe, which is OSGI container, and there is also Fuse Fabric, and it's a great framework to deploy multiple containers all around your network, so you don't have to configure. If you will have more brokers or more nodes of Fuse, you don't have to, manually configure it on each machine, but you can do it centrally from one container with Fabric, which will download the containers and all the needed data to another machine. Next there is Apache ActiveMQ, which is a messaging system I will be talking about. Then Apache CXF, which is for easy deployment of web services. And then Apache Camel, which is used for integration. You can specify some routing rules and then transfer data from some destination to another. So now I will tell you something about high availability, because when you deploy broker in the business, you need to ensure that it will be available all the time, because it's usually process business critical data, so you cannot afford to, when there is some failure, that your broker will go down offline. So it must be accessible all the time. And in Apache ActiveMQ there is multiple mechanisms to ensure high availability of your broker. First, I will mention some basic concepts which are involved in all mechanisms, and then I will go through the all mechanism one by one and tell you some about its advantages and disadvantages. So in every high availability scenario, you deploy more brokers, which logically forms only one broker. And one of these brokers will become master broker, and clients communicate only with this one broker. These slave brokers are in a passive mode, and they cannot accept clients' connections. They are only waiting if master will have some failure or something like that, then one of the slaves will become new master, so the clients can still communicate without any problem. The mechanism differs by election, because somehow it has to be chosen who will become the master, and also they have to somehow, when message is sent to the broker can acknowledge that message as received only after it's stored somehow safely. What does it safely mean? It depends on mechanism which is used. And client needs to also somehow know how to connect to each of the brokers. In a simple scenarios, it has addresses of all brokers, and it tries to connect to all of them, but only one of them will accept the connection because it's master. The other brokers are in a slave mode, so it's passive mode, so they will not communicate with him. So there are three mechanisms. First two of them are pretty similar because they use some shared data. In the first case, it's some database, and in the second case, it's file system. But this mechanism have lots of disadvantages. At most, it's that you have single point of failure, because when your database goes down or your file system goes down, you lose your data because it's only place where the data are stored. But replicated LevelDB brings advantage that the brokers, which logically forms one broker, don't have to share anything between them. They just communicate by exchanging messages, and slaves are kept in sync with the master. So I will start with shared JDBC. In shared JDBC, of course, you need some shared database deployed, and then the election mechanism works by locking of the database, because all brokers tries to lock the database, but only one of them will succeed. So this one will become master, and the other waits in a slave mode and tries periodically lock database again. So if the master will go down, he will lose the lock, and one of the slaves will get the lock and become new master. Messages are, in this case, are stored safely, can be acknowledged to the client that are received only in case they are successfully stored in database. So when the master receives message, he cannot acknowledge it. He first need to store it into the database, and after that he can acknowledge client that message was received. So here is a simple animation to show you how does it work. Because all broker tries to lock the database. Let's say that second server will succeed, so it will become the master, and client communicates with that master. In case of failure, both connections are lost, but all messages which was acknowledged to the client are now stored in the database. So one of the other brokers will become new master, and client has possibility to reconnect to it, so it can communicate, and no message is lost. So now we have a shared file system. It's pretty similar to shared JDBC, but locking is not implemented by locking the database, but locking a file, which is one little bit problem of it, because some shared file system do not have implemented file locking mechanism really reliably, so not all shared file systems are supported. For example, NFS3 is unsupported because its locking mechanism doesn't work that reliably, so you can end up with more master brokers, which is thing you don't want. So, but for example, NFS4 is working really good. So, but you have single point of failure, because you have to somehow ensure that your shared file system is somewhere safely stored, because if your file system goes down, you lose everything if you don't have any backup or something like that. So I have same animation. It works pretty much the same, just brokers try to lock a file on this file system, and one of them will succeed, so it can communicate with client. In the case of failure, again, there will be reconnect to new master, and because all messages are acknowledged to the client only in case that it was previously stored to the shared file system, then if some broker will fail, then nothing is lost, because the slave, which will become new master, can connect to the shared file system, fetch the message, and process it as it needs. Now I finally get to the replicated LevelDB, and its main advantage across the previous one is that you don't have to share anything at all. So there is no single point of failure, and everything is kept in the local storage of the brokers, but they exchange messages and try to keep their local storages in sync with the master. Only thing you need to have deployed is Zookeeper server, but in this case it doesn't play any role in storing messages or something like that. It's there only for election which one of the brokers will become master, but then it's play no role in, like some shared storage. So master is chosen using Zookeeper because at the beginning of the protocol, all brokers try to connect to Zookeeper, and they show which, or tells to Zookeeper which are latest messages they have. On the beginning, when you deploy this architecture, then every broker has 0 messages, so one of them will become master randomly. But in the later cases, when some master will go down, then slaves will have different messages replicated from the master broker. So the master will be chosen the one slave which will have latest message downloaded from the master. So when the master is selected, then slave brokers get from the Zookeeper address of the master, and they establish connection to the master broker. And first of all, what they do is the slaves will download all messages that master have stored. So they are in sync. And then after that, when master receives new message, it push this message through the connection to all of slaves, because it has connection to all of them. And message is considered to be safely stored only in case that at least quorum of brokers, which means number of brokers greater than half, has this message replicated. So in a case you have 3 brokers, you need to at least 2 of them have the message in local storage to be considered it's safe, and it can be acknowledged to the client that message was received. So here I have again animation. How does it work? So all brokers will connect to the Zookeeper server, and they will show him which messages they have, or tell what is the latest message they got. Let's say the B has the latest message, so it will be selected by Zookeeper as a master. Zookeeper will send address of the master to both slaves, so they can establish connection to the master and download missing messages. So then when client wants to communicate, it connects to the master and exchange messages. And every time master receives new message, it will send this message also to broker A and also to broker C. And after at least one of these 2 slaves will get the message, and master gets acknowledged that by the one of the brokers. Let's say it would be broker A. Broker A will acknowledge that message was successfully replicated. Then B can acknowledge to the client the message is in safe, and clients know that message is safely stored, even in case there is some failure. Because if now master broker fails, then connections from clients and both slaves brokers are lost. But slave brokers knows that there is no connection, so they go to the Zookeeper, and let's say the broker A have latest message number 24. Let's say broker C has latest message number 23. So they go to the Zookeeper and tells him what is the latest message, and Zookeeper will see that A has latest update. So it will elect broker A as a new master. So client can now safely reconnect to that master and start communicate. But C needs to connect also to master and download missing messages to be in sync with the master broker. So again, even in case of failure of one broker, nothing happens. So okay, now I will show you how simply you can deploy multiple brokers with replicated LevelDB in JBoss Fuse product. So I will switch the presentation here. Can you read it? Okay. So I have JBoss Fuse 6.1 distribution here. So I will extract it So and I will start Fuse. Fuse has also a really nice web console based on Untitled. I can show you here. Oops. Now it's running. But I need to log in, so I need to enable at least one user, because in the default settings no user is enabled. So I will enable user admin for simplicity. So now I can log in. And through this console you can manage running Fuse instance. There is ActiveMQ tab where you can see properties of the broker. So I can show you simply sending some messages to the broker. I have some simple client prepared here. So now I will start producer. I will send messages to destination called test, for example. I will send 100 messages and do half seconds timeout in between each message. So now it's starting to send messages, as you can see, and also you can see here in console that there is new queue created with name test. You can see there are 26 messages, one producer connected. It automatically refreshes, so it shows current number. You can also browse messages simply. There you can see all messages and their content. For example, this is message 12. Now I can start consumer, which will download messages from the broker. On the same queue, I will use less timeout, so it's faster, and it will download all messages. So you can see here that there is consumer connected and messages are being downloaded. So now queue is empty. So now I will show you how to create a highly available broker using replicated LevelDB. So first thing I will do is I will enable Fabric in that running Fuse instance, because it will be then pretty much easier for me to deploy more brokers, because I would have to start more Fuse and configure every Fuse manually. But with the Fabric, I can do that from web console. So I will just create Fabric in the Fuse console. It's just basically says that this running Fuse instance is managed by Fabric, so every configuration will be done using Fabric. It's not started yet. Yeah, what is? So now there is new option to switch to the Fabric perspective, and now here I can see MQ tab, where I can see all my running brokers. I have just one broker, and it's the one which is in the Fuse instance, which I launched manually. But now I can create more. So I will create group of brokers called HA, like hey available. Broker name would be replicated, and I will select that I want replicated broker. So it's create profile which contains configuration for the brokers, and When I will launch new containers, then Fabric will use that profile to configure all brokers to use replicated LevelDB store. Now it shows me your error. It's because I specified that I want 3 replicas of broker, but I don't have 3 containers running. So I will run new containers. Usually in a production, I would use SSH container and deploy Fuse on another machines, but for this simplicity, I will use child container, which will deploy all containers only on my machine. So I will create child container. It will use, as you can see here, MQ broker HA replicated profile. So now 3 containers are starting. It's basically starting new Fuse instances, but in this case only on my local machine. So it will take a while. I hope it will be fast. Now you can see it's provisioning the containers. So with Fabric, it's pretty easy to have more containers, because if I have no Fabric, I would have to extract 3 fuses and configure to everyone to run on another port and to use replicated LevelDB. But Fabric did all the work for me. And now you can see there is HA group with the replicated broker. There are 3 running containers, and this green background means that this one container is a master one, so client will communicate with this one. I can show you if I open options of a slave container and go to ActiveMQ tab. Nearly all properties says that broker is not yet started. It's because in a passive mode, because it's a slave broker. It should be somewhere here. When I open master broker, you can see all properties and it's running. So I can start the client to produce messages to this group. Just specify broker URL, which will be to use just discovery protocol, which will ask Fabric or Zookeeper which broker is master, and client will know to which broker it should send data. So Fabric and HA group, and it starts sending messages. And now I can show you that if I hotile, I will just see the containers, and this one is a master. So when I will stop this container, there you can see there was exceptions because it was communicating with the master, but this one was stopped. So in order to simulate failure. But it says that it's trying to automatically reconnect, and in the meantime the new master was elected, so it sends next messages. So it continues, it's successfully reconnected to another one. So now when I will run the consumer, which will fetch messages, it should download all messages, even if the broker was, the master one was stopped. So I will specify this. And it downloads all messages, but you know, messages 1 to 38 was sent to the one container and to the one broker, and 39 to another one. So it will be probably all of me. It's received all 100 messages because it starts from 0. It will be all of me. I would like to ask you if you have any questions.
Yeah. I have a
Sorry?
Then I have a running master
Yeah.
broker, and then I start. Okay, let's say that I have a master broker.
Okay.
I have some clients on it. Then I start a slave server, which will connect to it, and so initial synchronization will happen. And what if the load on the master is too big that our master is not able to replicate all the data to the slave? Is it in the way that master actually stops or pauses all the clients to synchronize all the data to slave, or it's just trying to do it on the fly?
It's just, every time the slaves will connect to the master, it tries to download all. But Zookeeper knows, because at the beginning all brokers connect to the Zookeeper. So Zookeeper knows how many brokers are there. So when the slaves connect, it can download it. Or did it explain your question, or can you?
It was more about what master does with the clients when the initial synchronization must happen.
It's continuing to communicate with the clients. It's just don't stop.
Just continue. Okay.
Okay.
Thanks.
Thank you. Thank you for question. Is there another one?
I would ask.
Okay. So.
Is there any other way how to set up the cluster instead of web clicking?
Yeah, it can be done using this console. There is command MQ create, for example, which will create the profile, which I did in the first step as I created the replicated broker, and there is container create SSH or container create container create child command with which you can create it all from the running Fuse instance. Of course, you can connect. You don't have to be at the computer where the Fuse is running. You can connect through SSH to the running Fuse instance, and you get this Carafe shell, and you can just invoke all commands.
Thank you.
Thank you. I'd like to ask, I was not really aware of if the replication protocol, if it's really tied to LevelDB or could be used for other persistence options.
It's really tied to LevelDB because LevelDB is mechanism how the broker stores data on its local disk. So it's tied to LevelDB because it's transferred this type of data to other brokers, to the slaves.
Yeah, okay. Thank you.
Thank you for the question. Any other question?
Yeah, actually, in case of deploying using the fabric, yes. Yeah. Who takes care about the Zookeeper? The fabric itself?
Yeah, there is when you create fabric, which I did with fabric create command. The Zookeeper is created on the node which I invoked it. So there is also a Zookeeper running in that Fuse.
Yeah, and there is only one, or in case of each in the deployment can be there two Zookeepers for that?
When you invoke this command, there is only one, but you can add more Zookeeper servers, so you get also Zookeeper reliable because you can have more Zookeeper servers running, and they share the same data between them.
Yeah, okay. And one additional about the thing, if you will have two data centers, and in both of them you will have two brokers or one broker, and which will be replicated. And when the one will fail, will the another will be voted as master?
In the case of replicated LevelDB, you have to have at least 3 brokers.
So it means that
because you have ensured reliability only if more than half of the brokers are kept in sync. So you need to at least 3 brokers. So
there is no possibility in case that I will have 3 brokers. I have to have 2 in one data center and 1 in another.
Yeah,
so if the one will crash, the one with 2 brokers, the network will be not working.
You mean if one broker crash, but there are still two running?
No. I mean, imagine the situation that you have two locations.
Yeah.
In one you have two brokers, in another you have one broker. So in total you have three brokers. You deploy this because you would like to have geographically replicated high available HA. And when the primary location where there are two brokers will crash.
When the two of brokers will crash, then it will not replicate because it's ensure you high availability only if less than half brokers.
Okay, thank you.
So if you wanna be able to survive crashing two brokers, you need to five brokers replicate. Okay. So
any more questions?
So okay, if not, then thanks for your attention and bye. Jo, už mi to dávali tady předtím. Dal jsem to tam. Děkuju.
Chceš si někam skápnout, nebo tak? To je dobrý, že? Toto. Co mě líbí? Proč? Tam háží jaký pěkný obrázky. Zrovna tenhle ne teda. No, teď u nás hledáme někoho na Series 7, kurně. Tak až to budete tady udělat, tak byste mohli například. Dobrá, tak já.
Co jde na prezentaci nějakou? Cože? Jde na nějakou?
Ne, já jsem vám tady chtěl jenom pustit, když budete mít přestávku, abyste museli koukat na tohle.
No.
Tak abyste se mohli koukat na ten Twitter wall, když jsem ho prakticky implementoval a tak.
No tak možná se musí toto skončit, ne? Prodat. Aby se to tam, nebo co?
No, tady mě si to ukážu. Jako
tady to nemá zatím, no?
Tady se načítá. Tady se to zatím načítá, ale... To mám už?
Hello. My turn now. At least 10 minutes. Yeah, 10 minutes.
So if you want to start, just go ahead. I have just this computer. You can connect and
Put stuff in.
Would you like some water? Sparkling or semi-sparkling or non-sparkling?
No sparkling. Just still.
to jenom se to přepne na tady ten počítač.
Jasně.
Když tak na tu přednášku to tam dejte radši oba dva monitory,
Jo, určitě.
Pokud nebude chtít výslovně jinak. reklamu a tak, takže to spíš ruší.
Jo, okay. Vaši tu tam spamujem. We will track time for you and we'll tell you when you have 10 minutes, 5 minutes, no Alright, time. cool. Okay? And just quick note, the questions are included to the presentation time.
Yes. That's why I shortened up the presentation.
Okay.
To remove like 5
Could you please upload your presentation here?
Sure.
We will attach it to the recorded videos.
Keynote is fine, format.